So we've already figured out how to determine the empirical formula based upon percent compositions by working backwards. Percent to mass, mass to mole, divide by small, multiply till whole. But that's the reduced form. We want to then have a way to get from the simplified version, the empirical formula, back to the actual molecular formula that the compound actually exists in nature. And so that brings us to our next piece of our mathematical puzzle, and that is our molecular formula. Our molecular formula is the actual ratio for a compound in nature. AKA the non-reduced form of the compound. Now we saw the example before of our butane versus its empirical formula. Remember the empirical formula, this has been reduced. For sake of kind of identification, I'm going to abbreviate EF as empirical formula. This would be the actual molecular formula, MF, as it exists in nature. Now if we wanted to, we could actually calculate the approximate molar masses of these two. Carbon we know to be about a mass of 12.01. That's going to be times 4, and we're going to add to that 10 hydrogens times 1.008, or about 1. And so we've got, what is that, 10 plus 48. So this has got a molar mass of approximately 58 grams per mole. Now, if we look at our empirical formula, the one that has been reduced for us, we can do the same thing. Find its molar mass. We got 2 carbons, so 2 times 12, essentially, added to our hydrogen, so 5 times 1.008, or approximately 1. So this comes out to be approximately, what's that, 24 plus 5. 24 plus 5 is about 29 grams per mole. Now you'll notice there's a pretty stark and clear difference as to how we got from this formula to the empirical, and how we get from the molar mass of the larger one back to the smaller one. We'll go from here to our empirical, we divide by 2. To get from our molar mass of the large one to our small molar mass, we do the exact same thing, divide by 2. Now here's the cool part. If we know this relationship between the molar mass of the large molecule and the empirical formula, we can actually work backwards to find the molecular formula using this mass relationship. And so your new step today is actually going to be to take the molar mass of your large molecule, so the molar mass of the molecular formula, the bigger number, I'll go ahead and put big there for us, the larger number, and we're going to divide that by the molar mass of your empirical formula, or your smaller or littler mass. Now when you do this, you should get a number. It's going to be a whole number. It's going to be, I don't know, 5 or 2. And what that whole number will tell you is how many times bigger the molecular formula is than your empirical formula. So you take that number and you just multiply it through your empirical formula to find the molecular formula. Let's take a look at an example. So if we take a look at, I don't know, HO. Sure, we've got hydrogen with a percent of 5.9. And we've got oxygen, percent of 94.1. And then we got some other information, MW, of 34 grams per mole. Now here's the deal. In order to find a molecular formula, you need to know 2 things. You need to know the empirical formula, and you need to know the actual molar mass of the big molecule, or the molecular formula. Now sometimes, that's MW. Sometimes it'll be disguised. So this will be MW as in molecular weight. Nope. But this is our molar mass of the large one. Now we don't have the empirical formula directly. We have the stuff we need in order to find the empirical formula. Well, we follow our steps from before. Percent to mass. If we assume a 100 gram sample, these become grams for us. Mass to moles using the molar mass for hydrogen is 1.008 grams for every 1 mole of hydrogen. For oxygen, it's 16.00 grams per every mole of oxygen. When we run those numbers through, we end up with 5.9 for the first one, and we get approximately 5.88 for the second one. Now we're going to divide both of these by small. Looks like 5.88 is our small one, but really it's going to come out to be a 1-to-1 ratio. What that means is our empirical formula is actually just HO, 1 and 1, if that makes you feel better. So now we know the empirical formula. We know the molar mass of the big one. We need to find the relationship between them. So we find our molar mass for our empirical formula. 1 hydrogen is 1.008 plus 1 oxygen, 16.00. That's going to come out to be 17.008 grams per mole. So now we take our big molar mass divided by our little molar mass. 34 divided by 17 gives us 2. Yay, we got a number. The number's 2. What do we do with that number? That number tells us that the actual molecular formula is 2 times bigger than the empirical formula. So we're going to take our empirical formula and we're just going to multiply it by 2. We had HO, we multiply it by 2, but we're going to show it as subscripts. This turns into H2O2, the non-reduced form of our compound. H2O2, for some of us that might recognize this, is hydrogen peroxide, often used for cuts and sterilization for anaerobic cellular growth to try to stop those species that don't like our oxygen so much. Follow these steps and you should be able to turn any empirical formula into the molecular formula. Good luck as you start to work some of these problems.